Log Minutes 6 and 7 will explore three of the major properties of logarithms. Since a logarithm is an exponent, these log properties will parallel properties of exponents that we've already learned. To explore the product rule for logs, let's review the product rule for exponents. To simplify z squared times z to the fourth, recall that what we do with these exponents is we add them. 2 plus 4 equals 6, so z squared times z to the fourth equals z to the sixth. So if for a product, we add the exponents. This means if we have the log of a product, log of x times y, that we want to separate into log base a of x and log base a of y. Since a logarithm is an exponent, we don't multiply the separate logs, we add. This is the product rule for logs. Log base a of x times y equals log base a of x plus log base a of y. This rule can be used forward or backward, this direction or that direction. We can separate log of 8t, which is the log of a product, since 8t means 8 times t, into log of 8 plus log of t, using the product rule in the forward direction, splitting into two logs. For log 3 plus log 7, we can use the product rule in reverse, to combine the logs into a single log. The rule in reverse would say, to put these together, we need to multiply the arguments. That's the 3 and the 7. So multiply 3 times 7 to combine this into the log of 3 times 7, which equals log of 21. To explore the quotient rule for logs, let's review the quotient rule for exponents. To simplify z to the sixth over z squared, recall that we subtract the exponents. So z to the sixth over z squared equals z to the fourth. For a quotient, we subtract the exponents. So we do the same thing for logs, since a log is an exponent. For the quotient rule of logs, we subtract the logs. Log base a of x over y equals log base a of x minus log base a of y. Using this rule in the forward direction, we can separate this log of a quotient, log base 2 of 5 over 9, into log base 2 of 5 and log base 2 of 9. And the quotient rule says to subtract these logs. So log base 2 of 5 minus log base 2 of 9. Using the rule backwards, we can combine the log y minus log 3 into the log of a quotient. The arguments y and 3 will become a quotient y over 3. The first argument becomes the numerator, the second argument becomes the denominator. Here are some mixed examples using the product rule and the quotient rule. In the first row, we have a single logarithm and the directions say to expand into a sum or difference. This is the forward direction of the properties. But we have to decide which property applies. So log base 8 of 5x, that would require the product rule, since 5x is a product. The product rule, recall, is addition. So we'll add log base 8 of 5 plus log base 8 of x. Natural log of 7 over 9 requires the quotient rule, since 7 over 9 is a quotient. The quotient rule is subtraction, so we subtract natural log of 7 minus natural log of 9. Note that the numerator becomes the argument of the first log. In the second row, we have 2 logs in each problem, and the instructions say to write as a single logarithm. This is the backward direction of the properties, but we need to decide which property applies. Product rule is addition, and quotient rule is subtraction. So if the logs are added, we'll use the product rule in reverse. If the logs are subtracted, we'll use the quotient rule. To combine log of 10t to the 5th minus log of 2t squared, since we have subtraction, we'll use the quotient rule. The single log argument will be a quotient, 10t to the 5th over 2t squared. And this quotient can be simplified. 10 divided by 2 is 5. Subtract the exponents, t cubed. So our answer will be the log of 5t cubed. To combine log of x plus 3 plus log of x minus 3, since we have addition between the logs, we'll use the product rule, since the product rule involves addition. The single log argument will be the product x plus 3 times x minus 3. Multiplied out by FOIL, this product is x squared minus 9. So the answer is the log of x squared minus 9. The exercises in the second row will be important when we solve log equations. To solve, we'll need only one log on each side of the equation. If we have multiple logs added or subtracted, we'll combine them into one log using the product rule if it's addition, or the quotient rule if it's subtraction.